Welcome to solverfy.
Okay, so recall that Raoult's law, right, is that the partial pressure of the ith component of a ideal solution is the partial pressure of the pure component I, the ith pure component, and chi I or xi is the mole fraction of the component I in the liquid or solid solution or our ideal solution, right? So this is true always, no matter how many components you have in a solution. If you have a pure ideal solution of a single component, this is true, right? And so the only thing that really changes when you talk about mixing things is that all of a sudden we can work in, Dalton's law, which says that the total pressure of everything in our ideal solution is going to be equal to the component, the sum of the component partial pressures, right, in our solution. This is true for liquids or solids. But it's in reference to the partial pressure of the pure component, or the vapor pressure of the pure component. So what I'm saying is that the total pressure, right, is going to be equal to the partial pressure of the components, right? So that's going to be component 1 plus component 2 plus yada, 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 all the way out to, if we have n components, the nth component. And so here we're talking about two liquids being mixed. We could call them A and B, right? Or we could call them 1 and 2. It doesn't really matter. But the idea then is that our total pressure is going to be equal to pressure 1 plus pressure 2, right? Liquid 1 and liquid 2. And then from our Raoult's law, we know that P1 is actually equal to little p one star, right? The partial pressure of pure component 1 with the vapor pressure of the equilibrium vapor pressure of pure component 1 times the mole fraction of component 1 in our solution, plus the partial pressure of component 2 times the mole fraction of component 2 in our solution.